Hi, everyone. While we're waiting for more people to come in, I just wanted to talk a bit about why we're having this webinar. It is part of the Caribbean Green Technology Center at UVI's Energy Month. And so this is National Energy Awareness Month, which is by DOE, and we have organized a few different webinars. And so this one is Back to the Basics, Renewable Energy 101. But next week, you can tune in to listen to Pro Solar talk about the different steps you need to take to install solar PV in your home. Following that, the Virgin Islands Energy Office is also hosting their own webinar about their solar savings calculator, which is on their website. And so this demonstration really fits in with that installation webinar because it shows you what you can do with the net energy billing program and what type of savings you can get from that. The next, on the 21st, we will have a webinar about powering through a blackout, which is a guide that we put out last month, which gives different options for what you can do to make sure that critical services are always happening. So whether that's solar cell phone chargers or a water pump that's powered by the sun, just looking at different solutions. And that will be, the 21st. The next one is a panel discussion between Martin Ford, who is an energy consultant at Rocky Mountain Institute from the Caribbean, Kyle Fleming, the director of the Energy Office, Doug White, who is a green architect, and Jerome Diaz, who is a engineer at WAPA. And so they will be discussing kind of their viewpoints on what the energy transition or renewable energy transition might look like for us here in the Virgin Islands. The final webinar will be held by the Hazard Mitigation and Resilience Plan team at UVI and the Keep Safe Enterprise Group, which is basically Keep Safe is a guide that is easy to understand and it helps you find solutions to make your home more prepared for hurricanes. This group started this initiative following Hurricane Maria in Puerto Rico, and so they have a great guide online, and they're going to be talking a bit about some of their strategies that you can do on your own for your household. Yeah, I see that somebody has their hand raised. I guess, or a few people have their hand raised. We can still wait for people to come. I don't know if you guys want to ask some questions now. We'll probably start with the webinar in 2 more minutes. So Michael, do you want to let them ask the question?
I would like to, good morning, everyone. I would like to introduce myself. I'm Greg Gronell. I'm director for the Caribbean Green Technology Center. So welcome, everyone, and really excited to have you participate in this first event.
Okay, so I see that the hand went down, so I guess that question was resolved. Well, I think we can get started. So thanks, Greg, for introducing yourself. I'm Ariel Stoltz, and I am the Assistant Director at Caribbean Green Technology Center. So some background about me. I grew up in St. Thomas, and I went to VIMSIA and graduated from there. Following that, I went to Brown University, where I studied mechanical engineering. Then I attended Carnegie Mellon University, where I obtained an interdisciplinary master's degree within the College of Engineering for Energy Science, Technology, and Policy. So, and now I'm currently at UVI at the CGTC. So we really focus here on energy and sustainability issues that are really relevant to either the university or to the entire territory. And one of our main goals is really to take some of the information that we learn and make it accessible to the public. And so that's kind of what we're doing today when teaching you about renewable energy. So during today's webinar, we will be discussing the different types of energy sources, how we use them to generate electricity. We'll also be looking at some of the potential resources that we have here in the Virgin Islands. So before we get into the energy webinar, then just a few housekeeping rules. So we can't see or hear you if you're attending, but please, if you have any questions, you can use the Q&A button and ask us those questions. Specify if it's a clarifying question so we can address it right away, or if it's just a general question or comment for the discussion. Also, you can use the chat room and make comments there. But generally, we will answer the questions that are in the Q&A. Following the presentation, we hope to have more of a discussion. And so if you would like to speak, just raise the hand. It's like a raise hand icon. And then we will unmute you so you can participate in the discussion. And we really do want to hear everyone's thoughts. So we hope that you take that time to join. And finally, just be respectful of others. Whoops. So to start off, what is energy? So the textbook definition says that energy is the capacity to do work. We also know there are different types of energy. There's kinetic, potential, gravitational, thermal, et cetera, et cetera. So although energy can't be created or destroyed, there can be conversions. And during these conversions, there can be losses as well. So maybe whether this is heat being emitted or friction, noise, these are all losses, and it's not always useful to us. And so another definition of energy from thermodynamics is that it's the equation of heat and work. And work is typically thought of as the useful part of that energy, whereas heat are losses in efficiency. So where does energy come from? It starts off as a primary energy source. So we can, these would be things like coal, petroleum, the sun. These are all primary energy sources. But it's not really useful to us humans yet. We have to convert it into something that we can use. So we usually use an energy carrier. The most common one today that we use is electricity. And so this allows us to transfer this energy to the services that we actually need for our everyday lives. And so these are what we really care about. It's kind of like the key message. Even though we'll be talking all about how we generate electricity, I want you guys to be thinking about the whole time, what do we use this energy or what do we use this electricity for? So we don't really care about how much gasoline we have. We care about getting from point A to point B. So if that can be done with an electric car or maybe better biking lanes and biking, that still gets us that energy service. And so that's kind of what I want you guys to think about when we're learning about all the different forms of energy conversion. So let's get started with the most common way to generate electricity, which is by spinning a turbine. So it sounds pretty simple. You usually will generate some high pressure, high temperature steam and use this to spin the turbine as fast as you can. This generator here works by a magnet spinning within the electric coil. And because those fields are perpendicular to each other, when you spin it, it can create a current. And that's how we get the electricity that we use. So yeah, if we try to do this without such a constant source, like maybe by hand or other forms, we find that it's not really fast enough to do it. But if we use something like the burning of a very high energy source fuel, or the wind, which can be very powerful, then this is where we get the results that we need to keep the lights on. So we've been using for many years, since the dawn of the Industrial Revolution, we've been using fossil fuels to generate electricity, or to generate any energy that we use. So in terms of generating electricity, these different fossil fuels, oil, coal, natural gas, are combusted and creating steam, boiling water to create steam, and then spin a turbine. In the Virgin Islands, we generally use oil to produce our electricity. So these different sources do have losses along the way. And they're usually connected to their environmental impact as well. So something like coal, it has about an efficiency of about 30 to 40%, meaning that 70 to 60% of the energy is actually lost. So meaning that the majority is actually lost. It also has many environmental emissions, whether this is air pollution from sulfuric acid or mercury, but also CO2 emissions, which are the main driver of climate change. Oil is the next, a bit better efficiency, a bit less emissions, only 3/4 that of coal. But it's still not that much better. The natural gas is thought to be the best of these three because it has about half the emissions of coal. And it can also burn at much higher temperatures because it can combust in air. And because of this, we can run the cycle again with water. So because of these two cycles, we are able to get efficiencies of up to 60%. Yeah.
So I would add
Yes.
to what Ayel just mentioned, two things. First, as was mentioned in the comments, in the Virgin Islands, we are also now using propane. So we are using a form of gas in the Virgin Islands right now, and has to do with what Ayel just mentioned in terms of, increasing efficiency, but also the cost associated with using this form of energy compared to the more sort of older source of energy and more environmentally questionable source of energy, such as diesel or other petroleum-based, different than the propane. And then the other thing that I would like to add to what Ayel mentioned is that all of this discussion about the type of fossil fuel to use is really, at the end of the day, to boil water to make a turbine run so that the generator would generate electricity based on her previous slide. So regardless of the type of and the source of energy that you use to make the turbine run, at the end of the day, electric generation is all about a coil, a magnet, and the rotation of one versus the other. And all we spend our energy when we talk about energy sources and fuel type, it's all about what is the most efficient way to boil water to make a turbine run. So just wanted to make that also clear to the different panel, the different attendees.
Yeah, exactly. And on the other side of that, so if we're boiling the water, at the end of the day, we need to cool that water back down so we can use it again in the cycle. And this does also has an environmental impact because it uses a lot of water. So most power plants are located along rivers, like ours is near the ocean. And this is because water is used in the cooling process. And so, for example, a coal plant would probably use like 1,000 gallons to just to produce 1 megawatt hour of electricity. Just to wrap up on fossil fuels, there are positive and negatives to these. So we often think of the negatives of fossil fuels, which I think makes sense, but I just want to touch on the positives in terms of why we're so addicted to them. Like, why is it hard for us to change? So one of the reasons is that it's easy to store. So it's easy to stockpile these fuels, and you can have them, you know exactly how much you have for like maybe 3 months, maybe even longer in advance. Another is that because you have that stockpile, it's a very steady source of electricity. Another is that in the US, at least, these are very abundant. And so one of the main things is natural gas became very abundant when we started figuring out how to use hydraulic fracking to get it out of the shale. And so this, it goes to my kind of third point, is that, you know, they always talk about like peak oil or the end of oil, but then we create a better way of getting it out of the ground. So technological advancement is kind of stopping us from getting away from these sources, because we keep finding ways to make them economically viable, even when we know that they're hurting our environment. And finally, the reason that we are so locked is because we are so locked into these sources. We have so much infrastructure around fossil fuels, whether it's power plants, which are very expensive. You know, a power plant or electric utility doesn't want to just stop using that capital that they invested in creating that power plant. Also, even like something like all the gas stations we have around, this is infrastructure that is already built and focused around fossil fuels. So the negatives, many of people probably know these, but it's a non-renewable resource. There's a finite amount. There's air pollution, which is very dangerous for human health. In addition to that air pollution, there's another air pollution, which it contributes to global climate change because of greenhouse gas emissions like CO2. But when we're talking about natural gas, whenever it leaks before it's burned, this gives off methane, which is even stronger than CO2. And then in the USVI, then we're really reliant on expensive imports of these fuels. And so that can be tough on our, we're also subject to global markets and supply chain, and we're usually at the end of that supply chain. So those are some of the drawbacks to fossil fuels.
I would like to add to what Aya said, that the point about climate change is not only the burning of the fuel for electricity, you know, for production electricity or for moving your car, etc., contributes to climate change, but the biggest emitters in the world are actually oil companies, because the process of extraction of the fossil fuel also generates enormous amount of greenhouse gases. So it's the production of the greenhouse of the petroleum product, as well as using those petroleum products, that are massive contributors to the global climate change sort of processes that we're seeing right now. So keeping that in mind as you know, a big negative of fossil fuel.
Yeah, and there's actually like another type of fossil fuel that's not commonly thought of as that, and that's nuclear energy. So nuclear energy, at least nowadays, is from uranium, which is mined. And so it does have upstream emissions, like Greg was just pointing out, when you are producing these fossil fuels. However, when you are using the fuel to produce electricity, it does not have any emissions. And this is because, although it uses the same process that we were talking about in the beginning of the turbine spinning from this high pressure or high temperature steam, for nuclear, a nuclear reaction is producing all of that heat and energy instead of combustion. And so nuclear energy is also a lot more energy dense. And so here at the bottom of the screen, you can see that one fuel pellet of uranium, which is like the size of your fingernail, has as much energy as 150 gallons of oil, a ton of coal, or 17,000 cubic feet of natural gas. So you can see that the impacts of mining that one little fuel cell is going to be much less than the impacts of mining these other fossil fuels. The drawback to nuclear energy is that the waste lasts for a very long time, and it is dangerous. In addition to this, it has the controversial side that it has the potential to become weaponized. And so that makes it a bit difficult to have this, this source everywhere in the world, even though it has no emissions and it is much more energy dense. So now that we've touched on all the fossil fuels, I would like to move to renewable energy. And so this is different than fossil fuels because it's replenishing on timescales that mean that we can use it for many generations. So to start off, one of the oldest sources that we've used to create electricity has been hydroelectric dams. And this uses the force of the water to spin a turbine and then generate electricity. Hydroelectric dams are not commonly built anymore because they do have a huge impact on the landscape and the river. And so it can be hard to put a new one in place because of all those impacts, and maybe even having people having to move out of the area because of those changes to the landscape. Other types of hydro power is wave energy and tidal energy, but these are usually very much newer and have not yet been commercialized, although there's lots of research and demonstrations and pilots going on. So maybe this is something in the next couple years, decade, that we'll see much more common, but for now it's really not commercialized. So wind is very much very prominent nowadays. So wind turbines use the wind energy to create electricity by spinning those blades. And the amount of wind energy is really proportional to that wind speed that you can get. And so that's one of the reasons why they're so high, is because the higher up you get, the more wind speed you can get. And also the more area you can encompass. And so you can get a lot more electricity out of building it up just a bit higher. You get a ton more electricity out of it. And so that's why they're getting bigger and bigger. Another form of renewable energy is biomass. And so biomass is usually the conversion of agricultural, food waste, maybe even trash, into a gas for heat or electricity. And this is, so biomass is actually a really old form that people are still using and use forever. Is like, just if you think of burning wood for any cooking or fuel to gain energy that way. And so biomass is probably the most used energy source in the world today, if we consider that, that side of it. But when we're talking about for electricity production, then it's really a much more a more sophisticated process with anaerobic digesters or processes like those. And so, one more thing to add about biomass. So a lot of people would consider biomass to be carbon neutral. And what I mean by this is during the plant's lifetime, it absorbs carbon through photosynthesis, and it stores it either in the plant itself or maybe in the soil. And so when you burn this plant, then you are just releasing the carbon that it absorbed. But one of the reasons why this is a controversial statement even is because when you're doing agriculture, transporting the fuels, all of these processes also take energy. And this does have a carbon emission or have an impact. So they're not always not truly carbon neutral. Some studies have found that it can be even have the same amount of emissions as using gasoline in terms of as a substitute, or sometimes even more, just if you look at those life cycle impacts.
So I would add to the excellent description that Ariel has given so far that, so keep in mind the sort of main difference between the renewable sources of energy that we've talked so far about compared to the sort of more traditional fossil fuel type source of energy. The diesel, petroleum-based sources sort of energy, such as diesel or methane or propane, etc. What we do is we burn them to boil water, to spin a turbine that then make a generator run. So that's how we get the generator to run, by burning the fossil fuel. The renewable sources of energy sort of sidestep that process of burning something. We actually use the energy in the environment to make the turbine run. So the waves make a turbine run, that makes a generator create electricity. The tides make a turbine run. The hydroelectric dam make a turbine run to make a generator create electricity. So except for biomass and the biogas that is emitted and then burnt, all the other sources of renewable energy so far do not require burning of something. We use the energy of the wind, the energy of the wave, the energy of the tide, etc., etc. We use the energy of the natural elements in order to create and extract energy out of a generator. So just want to reemphasize that point for you all of these are the sort of main differences between the two. But at the end of the day, a turbine has to run to make a generator create electricity.
Yeah, thank you. Most of these have to use a turbine. One renewable energy source that's a bit different is photovoltaic solar. And so it actually directly converts light photons to electricity by exciting electrons. So they jump energy levels. And when this happens many, many times, it can create a current, and then that's where we get our electric source. This creates a direct current. Most of those turbines spinning, because it's moving, it's kind of an alternating current. And so we do need to use an inverter for photovoltaic to make sure that we can run our appliances in the home, because they're all set up based on these fossil fuel generated things, which usually use alternating current, which you can see here is like AC versus DC. So there are other types of renewable energy, but we are not going to speak about them today. But if you have any questions, or would like to talk about them, definitely bring them up, and we can talk about them after the presentation. But for now, I'll just go through some of the positive and negatives of all renewable energy sources. So the first is that because it's renewable, it will not run out. It replenishes. We can use it many, many times and not worry about not having enough. It's also better for the environment because they don't produce emissions while generating electricity. Also, these resources are local to different regions. So for us, we have solar, we have wind, and so we can use these sources instead of depending on some imports of fuel. And finally, renewable energy sources can be distributed instead of centralized. And so this means that every home with a rooftop solar is now a mini power plant instead of depending on one source of energy. And so this can kind of help to build resilience, especially if we're looking at microgrids, which are increasingly popular. And so this can really help us to make sure that when disruptions happen, not everywhere gets cut off.
And
I
just want to clarify the term microgrid for everyone. Microgrids are basically small little contained power plant, as Ariel said. So they usually have a renewable source of energy, and then they have a fossil fuels usually type source of energy as well. So a small propane plant or a small diesel sort of generator, but they can create energy at a small scale that can be run independent of the main sort of grid, such as WAPA here in the Virgin Islands.
Yeah, exactly. Some challenges to renewable energy. The main one, especially for solar and wind, is that it's intermittent source. So it depends on the weather, basically. And it's difficult to cheaply store that electricity that you produce. And this is changing as technology improves, but it still is a big challenge to overcome. The other is the high initial cost of installation. I want to point out that this is initial cost. It's really like a one-time cost, because afterwards you're not repeatedly paying for those fuels. And so this high initial cost can be a barrier, but over the lifetime of the product, it's probably a lot cheaper. Another challenge of renewable energy, especially as we ramp up production, is that some of these panels or wind turbines, they require some rare elements or rare earth elements and other rare materials. And so as we, the call to electrify everything, this could become even more of an issue, especially some of these are mined in places with conflict. And so this is something people are quite worried about. And then as we mentioned before with fossil fuels, that everything is already set up for them, renewable energies work differently. And so our grid is not set up to integrate them. And so it takes some rethinking and a lot of planning to make sure that we can integrate them into what already exists, or maybe change the grid altogether. So now that we've talked about the different sources, the different primary energy sources, we're going to look at how much power we can get from all of these. And so we're going to really focus on how much renewable energy potential we have. So starting with the US, this is a map of wind resources in the United States. And so you can see, like, this is actually wind speeds. And so you would need to put a turbine somewhere to actually capture that and convert it to electricity. And so in the US, our population centers are probably on the East Coast and the West Coast, but we can see our wind is either in the middle or offshore. And so the issue is to transmission to get this electricity from where it's produced to where the people are. This is a map of solar, horizontal solar irradiance. This is, we can see similarly that the majority of it is in California, and whereas northern latitudes get much less sun. And so depending on where you live, this may or may not be a great resource for you. So what about the USVI? So this is a map created by the National Renewable Energy Lab for the wind potential in the Virgin Islands. And so you can see that as we get to the tops of the ridges, we see a lot more wind. And it seems like St. Thomas and St. John have more wind than in St. Croix. Another not shown on this map is the offshore wind potential. And so this is another, could be another option. The main issue is that our oceans are kind of occupied. We use them for tourism. We have coral reefs there. So anywhere with shallow waters is not going to be a great place to put a offshore wind turbine. And once we get deeper, then it quickly becomes too deep. And so these technologies are not able to be in such deep waters. And so, you know, there is research into floating wind turbines. In fact, my friend from Brown is working at a company designing these, but until they're available, it may not be something that we can use right now, but it is an option for the future. So how much power can we get in terms of solar PV? A lot, and it does range along the around the islands, and so it also ranges throughout the year. So if I can just switch here. So this is a it's loading, but this is a map showing the different renewable energies, or sorry, solar. It's in terms of peak sun hours. And so what that means is that when during the day is it shining the brightest? Or how many hours for the day does it shine the brightest? And so you can see that across the locations it changes, similar to the other map that I showed. But it also changes as the months change. So over here, you can see that in the summer months, June, July, then we get close to 7 hours, whereas in the winter, like December, it can get us more like 4.5 hours. And so, yeah.
Oh yeah, can you explain the different color scheme and how to interpret the map?
Yeah, so the colors are the more red areas means that you could get more electricity if you were to put a solar panel there. It also means that the sun, this is like how many hours a day the sun is shining at its full intensity. And so you could like click, I don't know, that you live over here, and then it will show you how much electricity you might produce that month, based on like what type of panel you have, how much roof area you have, and so forth. So, is it enough to keep the lights on? So we just showed you how all of the potential for renewable energy resources we have in the Virgin Islands. And the only issue is that it really does depend on the weather. And so, and for something like sun, if it's nighttime, then the sun is not shining. And we saw that over different months, the sun has different amount of intensity. And so I guess the answer is that yes, it's enough, but only if we're able to have energy storage. And so this is typically going to be a battery. And this technology is definitely improving. It's getting cheaper, and it really makes renewable energy something that, that we can consider. So yeah, just to, I guess, wrap up, at the beginning, I'd asked you guys to think about what do you use energy for? And so these different sources, these different types of primary energy sources can all get us to those energy services that we need. Just some of them have a much different environmental impact than others. And so I think this is really the key when we're thinking about, as long as we can get the energy that we need, then maybe it's in our best interest to look at something that is friendlier for the earth. Thank you.
So we have a few questions. The first question was whether or not we could build a waste to energy plant on the territory. The answer is, I typed the answer, but I will let you all know the answer in case you haven't read it. It's those type of projects are good in theory, but the initial costs are extremely high. It's a few $1,000,000 just to sort of properly build the plant. So you're looking at a very long payback period that you might not be achieving, especially given the sort of volume that we create here in the VI. So at the moment, we are not looking into it in the territory, at least UVI is not. But that doesn't mean that if somehow we can subsidize it, it will happen in the future. I just don't know. Another question, Ariel, is could renewable energy sources be best applied to microgrid energy systems?
Yeah, I think that renewable energy can be a very valuable thing to add to a microgrid. So as Greg explained before, kind of what a microgrid is, it allows you to have a like small scale power plant basically for one region and localize, have it very localized. And then some grids are interconnected to a larger grid. Some are just standing on their own. And so renewables work well as distributed energy sources. So they do tend to be a good thing to have for microgrid energy systems.
So another question is whether or not neighborhoods can create their own energy grid. I would answer it and then start, and then Ariel, you can continue. But I would say that, yeah, you can invest in creating a microgrid with your neighbor. You would have to come up with some very strong agreement ahead of time in terms of who's going to manage the microgrid, who's going to pay for the initial cost, and how that cost will be distributed among everybody who's going to be using energy. And then also long term, thinking about if somebody sells the house or not, what are the sort of consequences of that. So there are examples of community microgrids happening in the US, and they are very good to sort of create sort of resilience at the neighborhood scale. But there's a fair amount of technical and somewhat legal question that need to be figured out ahead of time.
I think, yeah, you answered it. So I see one about using ocean thermal or geothermal in the Virgin Islands. I think this is really good point. I didn't talk about these energy sources, renewable energy sources, mainly because geothermal, we do not have geothermal potential in the Virgin Islands, unfortunately. There are places in the Caribbean who do have this, and they are working to create ways to generate electricity from them. So that it is possible, but just not in the Virgin Islands. Ocean thermal, I know that in Hawaii, they are piloting some studies about ocean thermal and if it can work. It's a bit difficult to say because right now it's really not commercialized. And so it's kind of hard for us to be such a small island to, start doing this kind of like novel way of producing energy. It's better to stick with something that has a lot of like tried and true method. But ocean thermal, I think, has some difficulties in making it like producing enough electricity, basically.
I'm going to take the next question. Do you have any idea about the future of the solar field near Home Depot? I don't. I think WAPA is talking about building, ramping up capacity on St. Thomas from a solar point of view, but I do not have a sense right now of the timing and the location of those investments. They are also talking about bringing some wind to St. Croix, but again, I do not know the timing. One thing I want to say about wind, to follow up on what Ariel mentioned before, On St. Thomas, one of the biggest issue we have, with regard to bringing wind is the FAA regulation. We are a pretty small island, and so the FAA sort of zone where they do not allow for turbine actually occupies a fair amount of our land. And then after that, the issue is just land cost. We are a small island, very small footprint, and the cost per acre of land is fairly high. So there is sort of economic sort of calculation that goes into sort of buying land for electricity production versus buying land for development and bringing taxes. So those calculation and regulation make wind a difficult proposition on St. Thomas, St. John. But I believe that there are some plans to bring some wind to St. Croix, but I don't have a sense of where yet. Do you want to take the next question?
Sure. So the next question is, what are the current thoughts on the mix of various energy sources to ensure a reliable and consistent energy grid? I think this is a good question, because it mentions that like there should be a mix of sources. And so usually when we're thinking about the energy transition, we like to say there's no silver bullet. Because we need to look at, what are our strengths, what type of potential do we have, and utilize those strengths, and also make sure that we have like multiple sources. So wind and solar often like complement each other, because solar is the best in the day and wind is the best at night. And so having like both of these sources makes your grid a lot better. And also in the case of renewables, maybe having some energy storage or having a more consistent source to help ensure reliability can really help with creating this like energy grid mix.
So I would add to this that, when we looking at the grid, to Ariel's point about day versus night, it's really important for us to understand that dichotomy and, how much is happening during the day, how much is happening during the night. The energy power plant, they have a pretty difficult task. Their task is to always ensure that there's enough power on the grid so that everybody can access that power. So what it means is that usually they generate too much. But if you generate too much, then you waste a lot and you waste money because you burn fuel for no reason. So we know that in the morning, people tend to use a lot of energy when they wake up and, start the coffee machine or other things. And we know that it's the same at night when you come home and use the microwave or other devices and the lights. And then at night, there's also all the bars and restaurants that use a lot of energy in addition to the household. But around 3 to 4 a.m., energy consumption is probably dipping quite a lot. So the mix that you need to find is a mix where you can satisfy those peaks of demand, but also ensure that at all moments you can meet the sort of base demand. So it's to Ariel's point, the mix is a function of who we are, where we are, and what type of population and communities we are, as well as what can we get from renewable sources and what is it that we must produce all the time. Sometimes that can come from batteries, but at the moment, for most places in the US and in the world, it still comes from fossil fuel.
I guess I put up on the screen here the answer, your responses. We asked you, what are the barriers to renewable energy in the Virgin Islands? And this kind of shows what everybody answered the most in the biggest. I guess I just wanted to start a discussion from this question about if anyone wants to expand upon their answer or talk about what they think are the barriers. So you can raise your hand, use the raise hand icon, and then we will allow you to speak.
So I just want to, while you gather your thoughts, audience, I'm just going to go through some quick questions. Does the VI allow personal residencies to have wind power? I'm not aware of any law against it. I would say that you would have to check some height requirements. I know that on Water Island, I saw a pretty big wind turbine on a personal house. I don't know if it was permitted or not, but I'm not aware of any law against it. But again, FAA regulation really drive a lot of the sort of do and don't. UVI announced a plan to create a microgrid. That didn't happen, but we are looking into starting this again. And then the last one that I want to get before we get to your question is the coordination with WAPA. I think we are going to be looking into it, shortly, at least from a UVI point of view. And then example of renewable energy system in place in the Caribbean. I think Barbados and Puerto Rico have some pretty aggressive plans. Jamaica also is aggressive in that field, especially on solar. And then Dominica is investing a lot in geothermal because they have the volcano and the geology for that. So a lot of islands are moving very aggressively into the renewable energy world. And a lot has to do with a lot of Ariel mentioned at the beginning, which is independence and sort of separating themselves from global market sort of demands.
So I see we have some hand raised probably to speak about the barriers to renewable energy in the Virgin Islands.
Yes, I raised my hand if you can hear me.
Yeah, we can hear you.
Okay. I forgot to put a question and a possible barrier. I don't know, but I'd like your input. How are these towers that are going up on everybody's driveway emitting 2G, 3G, 4G, and eventually 5G radiation and electricity through your walls and into your appliances? How is that going to affect what's done with renewable energy? Because we have poles and wires and things going up in our neighborhood constantly, and it's in the middle of the night. We can hear them constructing and building and planting those poles in the night, and come out in the morning and see great extensions of wires and poles. And even people who are sensitive to the EMFs are getting sick from that. So how does that impact renewable energy if we wanted to do that in the neighborhood when these towers are all around? Thank you.
I'm not sure that it does impact. I think the telecommunication sort of processes and technology is separate from the processes and technology associated with, say, generating electricity from solar panels or generating electricity from wind turbines. So I don't think that one impacts the other one, but I'm not an expert on telecommunication. I would say that maybe you can have some interference if they are not designed and sort of placed properly from the electromagnetic waves. But again, I don't think that in the grand scheme of things, one impacts the other.
Does anyone else have comments on the barriers to renewable energy? I guess we can move on to some other discussion questions.
Actually, if I can just hold on one second, but somebody named Patasha Tracy, I believe. It seems that you made some comment in the chat about WAPA currently have plan for renewable energy project. Is that something that maybe you can expand upon a little bit? Please raise your hand if you wanna talk. Okay.
Hi, good afternoon.
Good afternoon.
I just found it quite interesting that WAPA does currently have plans for expanding its renewable energy resources, and we're kind of having this discussion in order to further our plans for resilience in the territory. And there just doesn't seem to be that that coordination that's needed, you know, as both of these things go forward from the different entities. And I'd just like to bring that to the fore to kind of, you know, perhaps forge some kind of communication that I think is really necessary if we are going to plan better for resilience and have renewable energy be a part of that.
So that's a very interesting comment. I believe your first name is Tracy or Patasha?
No.
So,
Patasha.
okay, Patasha. So that's a very interesting comment, Patasha. You are right that if we are moving to a more resilient territory, we need to be looking at how can we ensure that we have electricity, you know, for our needs, and this needs to come from different sources, since, you know, the hurricanes, for example, can really disrupt energy access for electricity access for a fair amount of people, and have some, you know, negative consequences, especially for vulnerable populations. So ensuring that there is, you know, access at different sort of scale, if you will, is a good idea. Such, you know, and the question that was asked earlier about, you know, can different, you know, house get together on a sort of microgrid, sort of, you know, is one example of how you can sort of create isolation or, you know, redundancy or resilience, you know, at a different, you know, level, so that when WAPA goes off, you know, a few people in that group can still have access to power. So I think your question is a good question. We will have hopefully somebody from WAPA participating in a panel discussion later in the month, as Ariel mentioned at the beginning. So keep an eye out for that panel discussion, because we will revisit this, you know, question of, you know, what is WAPA doing. But in the meantime, I just want to let you know that the Energy Office and CGTC are looking at updating the energy strategic plan for the territory. And as part of this effort, hopefully what we will be doing is sort of really try to understand what that mix of solution at different scale could look like. And we will be reaching out to, you know, people like you and others in setting like this one to really sort of understand this question of what do we want in a VI in terms of, you know, electricity. What is it that we absolutely must have for all of us, and how can we sort of distribute that from different sort of point of view or providers, whether it's household, community, or centralized. So we'll revisit this question later in the month, but also, you know, in the upcoming month as part of this planning process. But yeah, I don't have a clean answer for you, but it's a really good question that is worth exploring.
Thank you.
Do we have any more questions we didn't answer? We only have like 1 minute left, but if anyone wants to ask their question live, they can raise their hand.
There is one question. Can you suggest any relatively small wind generators which can actually put out some power? There are a variety of small wind generators. The ones that I'm most familiar with are the types that are used on boats. They produce 400 watts, maybe a little bit more. We will talk about some of those later in the month as we have a series called Powering Through a Blackout, where we explain, the type of small devices that, you can have. But I will be looking at, if there are bigger wind turbines that, you can have on your property. So I will be looking into it. We've mostly focused on smaller devices in our research, but we will be looking into maybe bigger devices, small turbines. I know there are some out there, and then we will post the information on the website. So please tune in October 21st for the Powering Through the Blackout webinar, where we will be discussing the type of small installation that you can have in your house. But you also check out our website for updates. We will be talking about this.
Yeah, and I think we're out of time for today, but thank you everyone for joining. And we do have other webinars coming up this month, which we hope you'll attend. If you registered for this event via Zoom, then we'll be sending you an email with those links so you can just sign up for any of the future events happening if you're interested. So yeah, thank you all for coming, and I hope that that you learned a lot and that we can get this discussion started about the transition to renewable energy in the Virgin Islands.
Thank you, everyone. See you next week.